Welcome to Calculations with Units. So, you should be able to do all of these problems without a calculator. So, put your calculator away. Don't use your calculator for any calculation in this video. So, in math, most calculations involve numbers without units. But in science, we almost always have units with our numbers. And this is because our calculations involve numbers obtained from measurements of physical quantities. And a measurement consists of a numeric value, the number, and a unit, or multiple units. You should always write a number with units in science. There are a few exceptions where you have a unitless number. But in most cases, almost all cases, you're going to have a unit with your number. And so you should always write that unit down. In a case where you have unitless numbers, they're generally derived from something, from some calculation where all the units have canceled. You could, and I would recommend doing this, keep the units there. So if you've got, say, meters over meters, it would cancel and it would then be unitless. I would recommend leaving the units of meters over meters. But in most calculations, certainly almost all of the calculations we're going to do for this class, you're going to need to include your units with your number. So you should never be writing a number down without units. In this class, at least. So units give physical meaning to a number. If I say 7, well, what does that mean? It doesn't mean anything all by itself. If I say 7 rabbits, now it means something, because there the unit is rabbit. So I have 7 rabbits. If I say 7 feet, you know that's a length. If I say 7 pounds, that's a weight. 7 grams is a mass. Remember that mass and weight are not the same thing. So the unit is what gives the number meaning. So units are the best indicators of what steps are needed to solve a problem. And units provide us a check that you have done a problem correctly, or a calculation correctly. So units are incredibly important. If you know the unit that you're starting with, and the unit that you're ending with, and you can lay out a path to get from this unit, the unit that you started with, to this unit, your ending unit, if you can lay out that path, then that's most of the work done for your calculation. Then it's just filling in numbers and writing it down. When solving calculations, the math must take into account both the numbers and the units. And we've got 3 rules. Rule number 1 is that the units must be the same in quantities being added and subtracted, and the answer has those same units. So let's look at some examples. If we have 5 apples plus 2 apples, we have 7 apples. If we have 5 apples and 2 oranges, we still have 5 apples and 2 oranges. We don't get to say we have 7 apples or 7 oranges, because we can't add apples and oranges. They've got to be the same. Now we could change this and say we have 5 apples and 2 oranges. We can say, well, I have 5 fruits and 2 fruits. 5 fruits plus 2 fruits is 7 fruits. But now we've changed the units. Right? We've changed the units from apples and oranges to fruit. But if we have something like 14.0 grams minus 7.5 grams, we know that that's 6.5 grams. So we have to have the same units if we're adding or subtracting quantities. If we don't have the same units, as in this case, then we can't add or subtract the quantities, because it just doesn't make sense to do that. So now let's turn to multiplying and dividing. Rule number 2 says when multiplying and dividing units, the units multiply and divide, which means that units obey the laws of algebra. So if we have something like centimeters times centimeters, our answer is centimeters squared. If we have centimeters to the 5th over centimeters to the 2, centimeters squared, then remember our rules for working with exponents. This is centimeters times centimeters times centimeters times centimeters times centimeters, 5 centimeters, multiplied together, divided by centimeters times centimeters. So 2 of the 5 in the numerator will cancel, when we cancel with the denominator, and that means that we have centimeters cubed. So essentially, you can replace any unit here with x. If we have x times x, that's x squared. If we have x to the 5 over x to the 2, that gives us x cubed. So the units follow algebra. Rule number 3 says when multiplying and dividing, group the numbers, exponentials, and units separately, and then solve each part separately. And then recombine the terms. So, if we want to calculate the surface area of a 2.0 centimeter times 4.0 centimeter postage stamp, we have 2.0 centimeters times 4.0 centimeters. Let's group our numbers and our units separately. In this case, we have no exponentials. So our numbers are 2.0 times 4.0. Our units then are centimeters times centimeters. So 2.0 times 4.0 is 8.0. And centimeters times centimeters is centimeters squared. And if you have an exponential term or some exponential terms, then you put those in there as well. So you must include the calculated units with your answer whenever you do a calculation in science. If you just write the number down without the units, you haven't finished the calculation. And your number then is meaningless because, again, the units are what give your number meaning. So you can always do the exponential and unit math in your head. You should only use a calculator for the number or coefficient math. You don't need a calculator for the unit math. You don't need a calculator for the exponential math. So if more than one unit is involved, then do the math for each unit separately. So if we have something like this, 4.8 grams times meters divided by seconds squared times 3.0 meters times 6.0 seconds divided by 9.0 times 10 to the minus 4 meters squared. And we want to know what that equals. We need to do the number math, the exponential math, and the unit math separately. So we're going to separate them out. We're going to separate our calculation into 3 parts: the number or coefficient math, the exponential math, and our unit math. So we'll pull all of our numbers: 4.8 times 3.0 times 6.0 divided by 9.0. That's this first set of brackets. The second set of brackets is now we're looking at the exponential terms. We only have one exponential term here. It's in the denominator. So we have 1 divided by 10 to the minus 4. And now we're going to look at the unit math. So we have grams from there. We have meters from here. We have meters from there. We have seconds from here. And now let's look at our denominators. We've got seconds squared there. And we have meters squared here. So now we'll do the math. So do the coefficient math, and that ends up being 9.6. Now we do this math. So 1 over 10 to the minus 4 is 10 to the plus 4. So we've got our 10 to the plus 4. And now here we have meters times meters divided by meters squared. So the meters squared on the top and the meters squared on the bottom cancel. The grams, there's no grams on the bottom, so that has to stay. So we've got grams there. Here we have seconds on the top and seconds squared on the bottom. So this is seconds to the first divided by seconds squared. So the 1 second on the top cancels with one of the 2 seconds on the bottom. And so we're left with grams over seconds. So we have grams over seconds. So our answer overall is the combination 9.6 times 10 to the plus 4 grams per second. So we can write our units in that last example as either this way, grams per second with a slash, or we can write it as grams times seconds to the minus 1 power. Personally, I think that this format, the x over y format, is the easiest to work with, so that's the format that I recommend you use. I would recommend keeping the same format all the time. You're probably going to see both formats in problems, but I would recommend whichever format you choose. If a number is given to you one way, write it down the way that it's given to you, and then immediately convert it to whichever format you choose. Again, I recommend this x over y format, although I recommend not writing it that way. I recommend writing it that way instead. Actually put one over the other, and this is going to use a little bit more paper, but paper is cheap. So that was calculations with units.